Hey everyone, and welcome to today's Explainer. Get this, every single minute, a staggering 500 hours of video are uploaded to YouTube. It's almost hard to wrap your head around, right? Well, today, we're tackling the ultimate Day 27 challenge from our source curriculum. We're gonna map out the actual real-world system design that keeps massive platforms like YouTube and Netflix from just completely crashing under all that weight. We're gonna break down the exact architectural flow required to make these streaming giants operate.
So how in the world does a system actually manage to serve millions of gigabytes of video seamlessly? I mean, when you kick back and click play on a video, there is this incredibly highly orchestrated sequence of events that triggers behind the scenes. Our source material today strips away all the magic and gives us the raw, structural logic that makes the whole shebang possible. Let's dive in.
Here is our roadmap for today. We'll start with designing Netflix and YouTube, then move to entering the system, followed by the core logic. After that, we'll look at processing and storing video, and finally, crucial system focus areas.
Okay, Section 1, Designing Netflix and YouTube.
The curriculum designates this topic as part of the final 4 days of study. And that makes total sense, because designing something at the scale of YouTube or Netflix, that is definitely not a beginner's exercise. It's really the pinnacle of system design. It tests how we handle truly unprecedented scale. After weeks of building up fundamental knowledge, Day 27 is where it all finally culminates.
Moving right along to Section 2, Entering the System.
Every single time you tap on your phone, you're kicking off this massive top-down waterfall of data. Users initiate the flow, which hits the DNS and CDN, and then those requests are immediately routed down to the load balancer. This is basically the initial gauntlet that every single click has to survive. You can think of the DNS and CDN as the initial receiving dock. The DNS is basically the map. It tells your request where to go. Meanwhile, the CDN, which stands for Content Delivery Network, is trying to hand you a cached copy of the video from a server that's geographically close to your house. That way, your request doesn't have to literally cross the globe just to fetch a single file.
Now, once you're past that initial gate, the load balancer catches the traffic. It acts as this massive, high-speed sorting mechanism. Its whole job is to distribute the weight so that no single server below it gets absolutely crushed if, say, a new video suddenly goes viral. It sits right below that gateway to keep everything moving efficiently.
Okay, so from the load balancer, the traffic plunges even deeper. It hits the API gateway and then scatters out to the microservices. The blueprint here is super strict and hierarchical. It carefully filters and directs requests layer by layer.
The API gateway sits right here, acting like a super efficient traffic cop, making sure your request gets pushed out to the correct, specialized worker. It takes that perfectly balanced load and translates it into specific commands for the system's internal network. It's the definitive threshold between the outside world and the platform's actual internal brain.
Which brings us to Section 3, the core logic.
This is where the microservices come in. They take on the specific tasks required by your initial request. You see, instead of having one giant, clunky, monolithic application trying to do absolutely everything at once, the system is broken up into these independent, specialized units. And they are all taking their cues directly from the API gateway right above them. The architecture actually forces a very strict path downward. Microservices check the cache first, and they only dig into the databases as an absolute last resort. I mean, every millisecond counts when you're sitting there waiting for a page to load, right? So the microservices don't just blindly go digging for information, they follow a highly optimized route.
And that cache? It essentially acts as the system's short-term memory. By sandwiching it right between the microservices and the databases, the system can instantly serve up viral, frequently requested data. This saves an immense amount of computing power and drastically reduces those annoying load times.
All right, Section 4, Processing and Storing Video.
Here's where we hit a massive structural fork in the road. Your standard databases handle lightweight text, things like user profiles, comments, or search queries. But massive, bulky media files, they require a totally different environment called object storage. Think about it. You simply can't shove a 4K movie file into a standard filing cabinet, right? You need a specialized warehouse.
So, from object storage, the data drops down into video processing and finally lands in the message queue. This is essentially the factory floor. It's where the raw media content itself is managed, transformed, and queued up to be delivered to the world.
When a raw video lands in the system, it requires some seriously intense processing. It has to be duplicated and formatted into dozens of different resolutions. Why? So it plays just as smoothly on a massive 70-inch smart TV in your living room as it does on a smartphone over a weak 3G connection on a train.
And sitting pretty at the very bottom is the message queue. Because processing video takes immense time and computing power, the message queue acts as this ultimate automated manager. It lines tasks up perfectly so the platform doesn't just gridlock itself to death trying to do everything at once.
And our final section, Section 5, Crucial System Focus Areas.
Look, you can have a picture-perfect structural blueprint, but if you don't zero in on 6 specific pillars, the entire factory is going to collapse under its own weight. Those pillars are video upload, transcoding, streaming, recommendations, the CDN, and scaling.
2 of those focus areas, scaling and the CDN, remind us exactly why that initial front door we talked about is so absolutely vital for global reach. A brilliantly designed database or microservice architecture is entirely useless if the system can't scale to meet sudden demand, or if the CDN isn't properly caching content at the very edge of the network to keep things fast. The other 4 pillars represent the core ecosystem. Upload gets the data in, transcoding formats it for different devices, streaming delivers it smoothly, and recommendations, well, they keep you on the couch for just one more episode, don't they? Everything in this complex structural design ultimately serves those 4 primary functions.
So to wrap up this explainer, looking at this incredibly intricate top-to-bottom flow, it leaves us with a pretty compelling question about that final focus on scaling. From the CDN all the way down to the message queue, when you are designing a system for billions of users, where is the most vulnerable bottleneck? What's going to break first? Next time you seamlessly stream a movie on a Friday night, just take a second to think about the absolute marvel of structural logic happening in the milliseconds behind your screen.